Hello everybody, welcome back to another video series. This unit only has two videos from me at least, and we are going to be talking about simple t-test in this video, and then in another video we will talk about ANOVA. So let's go ahead and jump right into the video. All right, so the first thing we're going to talk about today is t-test, and I'm going to show you some of the PowerPoints because some of the things I'm going to go through are a little bit conceptual, and then we'll head over to the SPSS portion. And I believe Dr. Ko is also going to add to this, but I feel like it just kind of helps kind of set up for what we're about to do. And also at any time you can always pause the video and just read the slide for yourself. I'm not going to go over every detail of it, just kind of the highlights. So as a reminder, a t-test is what we use when we want to compare two means. So there are multiple types of t-tests that we can do, and we're going to focus on the independent and dependent types of t-test. So in an independent t-test, the two means that we are comparing are going to be completely independent of each other. So for example, maybe we have a treatment group and a control group, and we're going to compare the two means. Or maybe we're looking at test scores for two different schools. And so we have school A and school B, and we're looking at the means of those two and making a comparison. So the two groups are completely independent of each other. We could also do a dependent t-test, and in that case, of course, the group is dependent. So in this case, we might think about a pre-test or a post-test, and the two means that we are using come from the same group. Okay, so we're usually thinking about two different time points. When we're looking at the means of the t-test, the most important thing that we're looking for is the determination of statistical difference. So if the two means are statistically different from each other, then we can confidently say that the outcome did not happen by chance. So we would be able to say that the treatment did in fact work in that independent t-test we ran, or that there is a statistically significant difference between the test scores from school A than from school B. And when we say that something is statistically significant, what we're saying is that it didn't happen by chance. That's one of the things we're always trying to demonstrate, is that our findings did not happen by chance, and statistical significance is what allows us to do that. We're going to put a pause on that concept for now, and we're going to think about distributions, but we will come back to that statistical significance in just a minute. So we're pausing for statistical significance for a minute, and we're going to think about distributions. So up to this point, we've been using z-tests, which have a normal distribution. And this image, I just liked the image. I'll drop the link for where I got it from in the description down below. I don't know anything about the site. I just liked the image though, so we'll put that as a caveat. But anyway, so this is what a normal distribution looks like. And when we use the z-test, we basically force it into a normal distribution. And so we're going to get this nice bell curve shape that is the normal distribution. But this isn't true for t-tests. For t-tests, our distributions are going to look a little bit different based on our sample size. So let's hop over to that and I'll show you what that would look like. This visual is showing us the different types of distributions that we can get out of a t-test based on the sample size. So if you look over here, we have our distributions and we have our different lines that are represented in the distributions, and then we have DF. So DF stands for degrees of freedom, and we get that number by having our sample size minus 1. So that degrees of freedom is directly related to our sample size. So if we look at the red line, we see the DF equals 1. So we would have a sample size of 2 in that case, and then we can see that it is increasing, and that dotted line is giving us a point of reference to see the normal distribution. So we can start with that, and we can see how low it's going down here at the bottom, and how much closer it is getting to 0. And we can follow that dotted line through, and we can see that that is the normal distribution. So now if we compare that to the red with our degrees of freedom with 1, which is very, very small sample, we can really see how different that distribution is. And as our sample size increases, we are approaching a normal distribution. But what's important to know is that our t-test distribution is going to look different for everything that we run because it is very much based on the size of our sample. Our t-test is something that can be used when we do have a smaller sample size. And by smaller, we're looking at less than 120. So a t-test is helpful when we're dealing with that small sample size and also when we don't know our population parameter. So the important thing to remember is the larger our sample size, the closer it will get to approaching a normal distribution. Now that we have framed our thinking around independent and dependent t-test, we are going to run through an example. So this Framingham SPSS sample is available to you, and this is what we're going to use for our samples in the videos. So our question is, how does systolic blood pressure differ between those who were and were not taking this antihypertensive medication? We know that this is going to be an independent samples t-test because we are looking at, our keywords are who were and were not. So we are going to think about our two variables. So actually, let's go ahead over to the next slide, because that's always going to be our first step. When we are making these decisions, we always have to think about what type of variables do we have and what can we do with those variables. So our first step is to think about our variables, and one of them is the continuous variable. So that's our blood pressure. Our blood pressure is a continuous variable where we're going to get that mean from. The other variable is a categorical variable with two categories. So our two categories are those who were taking and those who were not taking. So those are our clues within this little word problem to know that we are doing an independent samples t-test. And then we also know what the values of the categorical variable are. So let's then head over to SPSS and run this independent samples t-test. So all we're going to do is we are going to go up to Analyze, then we're going to go down to Compare Means and Proportions. Then we will go over to Independent Samples t-test, click on that, and then this box will pop up. So we need to put our variables into two different places. We have our test variable and our grouping variable. So our test variable will be the continuous variable. So that was our blood pressure. So then we're going to go over here and find that variable. Then we'll click the arrow to send it on over. Then we're going to find our grouping variable. So our grouping variable is the one that will define our two groups. So our treatment group and our non-treatment group. So if you remember, that was those who were and those who were not taking that antihypertensive medication. So we're going to go down here and click on that and click that over to grouping. So notice that it has question mark, question mark. So we have to define our groups. It will automatically set it as group 1 and group 2. But if you run it this way, it's not going to work. So let me show you why, because we actually need to do one step right before this. So I'm going to hit cancel, and we're going to go over to our variable view, and we're going to keep this variable in mind. So we're going to click our variable view, and we're going to head over here to that variable, and we're going to go over to the values, and we're going to click on that, and notice that our values are 0 and 1. So we actually need to set our groups as 0 and 1. So now we're going to come back over to our box. We're going to define our group. Let me move this, and we're going to define our group as 0 and 1. And then we'll click continue, and we should get our data set. Actually, first we need to click OK, and then we'll get our data. So let's first look up here at our group statistics. So we have our continuous variable right here, and then we have not used and currently used. So if you remember, the N is our sample size. So we had 231 people in our sample size who are not currently using it, and then 27 who are currently using it. We have the means for both groups. We have the standard deviation for both groups and the standard error for both groups. So now we can come down here to our independent samples test. And now we have some more things to look at. So we have our continuous variable here, and we have equal variances assumed and equal variances not assumed. What we are going to look at is that equal variances assumed. We're going to skip over here to the t number. It's negative 5.213. That DF is the degrees of freedom, which I was talking about earlier when we were looking at the distributions, and that should feel familiar because if we come over to our sample size, if we added that up, we would have 257, and then we subtract it by 1, and we get 256. So that's our degrees of freedom, and then we're going to look at our significance. So we have our one-sided and our two-sided. So let me just take a quick minute to show you that in case you have confusion over one-sided and two-sided. So let's head over here. So we're just going to use our normal distribution to look at it again too. But when we're thinking about one-sided or two-sided test, all we're talking about is these tails. Sometimes you'll even see a one-tailed or two tails. We're talking about this little portion like right here to the end or right here to the end. So in a one-tailed test, we are only going to look at this side. So wherever our cutoff, usually it's going to be 0.05 for our p-value. So let's just assume, I think for this project, everything will be set at 0.05. So on a one-tailed test, we would cut it here and we would only be looking at this side. So we use a one-sided test when we're considering direction. So if we're using words like greater than or less than, that's when we use our one-tailed test. Other than that, we are going to use two-sided. So that means it would be half of 0.05 here, colored in over here, and then half of 0.05 and colored in over here. And we're looking at the two tails. So that's all that means. I think we're pretty much, for this assignment, going to assume our two-tailed test at the 0.05. So let's go ahead back over to that slide. And now that we understand that, we can see that it wouldn't matter which one we used, they are both less than 0.05, which means that it is statistically significant. Our interpretation would sound something like this. Participants taking blood pressure medication had statistically different systolic blood pressure than participants not taking blood pressure medication, such that those taking medication had systolic blood pressure about 22.7 mmHg higher. And we're getting that 22.7 from our mean difference here. So remember, going back to the original point of t-test is comparing the differences. And so we have our mean difference here is that negative 22.7 averaged up. We could also look at our standard error difference, and we could also look at the lower and upper bound, and this is that range. So remember, if we set our p-value as 0.05, that means we're looking at a 95% confidence interval, and so we have our lower bound and our upper bound within that confidence interval. All right, we are moving right along. So let's head over to another type of word problem. This one asks, does systolic blood pressure change over time? So let's go ahead and break this question down. So again, we're thinking about t-test, which means that we are looking at means. And in this case, we are looking at a change over time. So in order to determine a change over time, we are looking at the same group of people. So in this case, we want to know a pre-test and post-test, if you will, is the easiest way to think about it. We could also think about it in terms of 2 time points. So at time point 1, what was their blood pressure? And then we have a series of time that passes, and then we're going to look at it again. And so we would be able to answer the question, does it change over time? And in that case, we are going to use a dependent paired samples t-test. So let's go ahead and do that. So as always, we are going to think about our variables, which of course we talked about. Our variable is that blood pressure. And this time we are thinking about 2 continuous variables. So because we are thinking about blood pressure in both cases. And so we have 2 continuous variables for this one that we will be making a comparison against. And let's head back over to SPSS and run this test. This time we are going to go up to Analyze. Then we're going to go down to Compare Means and Proportions. Then we are going to go to Paired Samples t-test. To this one, click on that. And now this screen is going to pop up. And so remember, we're working with time point A and time point B. So we're going to go over to that systolic blood pressure where it says 1, because that is time point 1. So we'll click on that and we'll move that over. And notice that that set that as 1. So now we are going as variable 1. So now we need to find the systolic blood pressure 3, I believe. So let's go ahead and find that. So it's here. So we're going to click on this and we're going to move that over. And so now we have our 2 variables and our 2 time points. And we're going to click OK. And this is what pops up. So we'll go ahead again, we'll look at our paired sample statistics, and we have over here, we have the pairing that we're looking at. We have our time point 1 and our time point 3 that we are comparing, and we can see that the means are different between the 2 time points, and we have our sample size, so our sample remained consistent over the period of time. Then we have our standard deviation, which also notice that that changed. Our standard deviation increased along with our mean. And then we have our standard error. Then we can come down here to our paired samples correlations, and we see that it's 0.561, so about 0.6, which is relatively strongly correlated. And then we have our significance for our one-sided and our two-sided. But let's go ahead and focus our attention to this table here. So we have our mean as set as a -10. We have our standard deviation. We have our mean error, we have our 95% confidence, so we have our lower bound and our upper bound, our t-test, our degrees of freedom, and again, our significance is less than 0.001, and so this is statistically significant. So for this, our answer would sound something like this. Systolic blood pressure does change over time. So we notice that because of our mean and the difference. So that -10 is coming from the difference between these two numbers. So we know that it does change over time. So that's the first part, the first parameter of our statement is systolic blood pressure does change over time. Between periods 1 and 3 in this study, systolic blood pressure increased by 10.6 mmHg. Then our last part would say that this is statistically significant. If you are curious about the -10, in this case, it's just finding the difference between the two. So that's why it's the negative, but it's the 10 points that we're concerned about. So we're thinking about that absolute value, that it increased. And that is it. Hopefully you feel like you have a good understanding of how to run an independent t-test as well as a dependent t-test, as well as how to get around some of the little hiccups. Make sure you always check your values before you run something. And always think about your variables and what kind of variable are you working with and how can it be used, because pretty much all of your statistical testing will 100% depend on the types of variables that you have and what you can and cannot do with those variables. But it is great to see everybody again, and we have made it midway through the semester. So congratulations on that, and I will see you in another video very, very soon. Bye for now.